our keynote speaker, Professor Siba Sankar Mahapatra sir, and higher academic grade, Department of Mechanical Engineering, National Institute of Technology, Rourkela. I am feeling blessed today to welcome him as his academic career before I was born in the year 1986. He is a doctor in the manufacturing field from IIT Rourkela. Within his vast experience of 40 years, he has guided 30 brilliant scientific minds of the country in their doctoral journey and 68 MD students, leading to 356 well-recognized international scientific publications and 256 international conference talks. Furthermore, he has 36 articles and 68 conference talks in various national platforms and contributing to national growth. In addition to this, he has 25 book chapters, 4 patents, and government-funded projects valued up to 2.4 crores. Cited to his career, he is honored with 20 awards from not only national but also international bodies at various stages of his career. He is also one of the top 2% scientists in the world, consecutively in the year 2020, 2021 and 2022. So, I would like to invite you in front of you all people of a good round of applause for this sir. Please welcome you, sir. Thank you, sir. A warm welcome to you, sir. Now I hand over the question to you, sir.
Thanks,
Mr. Sir.
for reading out extensive biodata. I welcome you. I welcome you all the participants
Mr. Sir.
and all the professors of this institute for witnessing my talk. So before delivering the talk, the game is very clear. If there are any doubt in mind, you please ask me at any point of time. I shall be talking on Industry 4.0 and 5.0. What is its status, perspective, and Indian context? This is a new technology. In fact, not a new technology, but it is a assemble of all the adjacent technology, and a new name is given by German scientists as Industry 4.0. And additive manufacturing, what we call the initial development of additive manufacturing was called the rapid prototyping, because only prototypes were built in those periods in the 90s and 80s. Only the prototypes were built. Later on, it came as mass manufacturing and named it additive manufacturing. Of course, with the additive manufacturing, some limitations are there, particularly the material limitations. All the materials cannot be made through additive manufacturing. Whether it is plastics or metals, additive manufacturing has its limitations. And you have heard so many lectures on additive manufacturing. Can anyone tell me what is the major application of additive manufacturing? In which industry it is applied more? Anybody? Don't talk about the space technology. What is that? Yes, exactly. It is in the medical science. Additive manufacturing is a profound application. And next to medical, it is the jewelry industry. In jewelry industry, it is a wide application. Of course, in the space technology also will be used. But exploring how to use the additive manufacturing in medical applications. And you can Google it and see the Mad Max medicine, some industries there in Chandigarh, some hospital is there in the Chandigarh, and Dr. Singh is expert in changing the reefs, change reefs, so the additively manufactured parts. Okay, so in orthopedics it is a lot of application. Anyway, before going to the Industry 4.0 and 5.0, let us talk about how the industrial revolution has taken place. Can anybody tell me what is the industrial scenario long back? Long back, very, very old days, what is the industrial scenario? How the industries has come? Previously, in long back, there was no industries. Everything is called a cottage industry. People were specializing in some products, like weavers, potters, they were specializing in that. And they used to develop the parts and sell in the weekly markets. That was what the industry. Okay, and there was no the marketing system was not existing. It was the butter system. Okay, they did the products, and in exchange they used to get the rice or something like that to maintain their daily life. That was the industry. And what is the advantage of that? The advantage is that when you are creating something, you wholeheartedly involved in that, building that part. Okay? Because when you are making a shadi, then wholeheartedly you will try to design it, how it will look, how it will be, how attractive it will be in the market. That was their concept. And they were the really the, not only the businessmen, they were the creators. They were creating something. Later on, industrial scenario previously it was manual industry, like the mechanized product. Now, you look at the industries, how it has changed gradually. In the 18th and 19th century, the industry started because of the development of the steam engine. When the steam engine came, then power came, and mostly that were applied to textile industries. Then the power looms came. Okay, so gradually we are shifting from the cottage industry to the power looms and textile industries, and gradually from the rural sector we went to the urban sector. Okay, so initially there was a rural sector, then we went to the urban sector. Then we started creating the labor. This is very important. We created the labor, those who are working in the industries. Next. Then previous one. Then in the late 19th and 20th century, electricity was developed. Then there was many things were mechanized. And we focused on mass production and profit. Businessmen or the industrialists, they wanted the profit. Profit was their motto, rather than how to trade and sell the market. But the whole scenario changed, and they were making money. So, in that period, we formed the mass production, and we forced mass production. the car industries were developed. Okay, so by this process, what we lost? We lost one thing, that is the creative attitude, creativity of the labor that we lost. And we just created the labor, division of labor, where there will be then there will be lathe operator, welders, like that. Based on our profession, we created the labor class. Now, what is wrong in that? No doubt we improved the productivity. They were very productive. They were meeting the market demand. But the labor are human beings. We lost their, we could not use their mind, their creative attitude. Anybody who has seen a movie by Charlie Chaplin, Modern Times, anybody who has seen that movie? There is a movie known as Modern Times by Charlie Chaplin. Anybody seen that movie? If you get a chance to just to watch that movie, there is a very interesting story in that movie. Okay? There is a conveyor belt, and Charlie Chaplin is a labor in his factory. Yes, conveyor belt, and his duty is to just tighten the nut.
Yes.
His duty is just to tighten the nut. How fragmented the task is that we look at. His job is to tighten the nut. Now, he was so involved in the tightening the knot that when he was going in the roads also, he moving his hands as if he is tightening the knot. That was the result of this division of the labor. That we have the work is so small and divided like that, and the people have no choice but to just do that duty and not to use their brain, nothing. Then these days, after so many years, we thought of job enrichment, job enlargement. If you go through the management theories, people talk about job enrichment. Then we created multifunctional workers. They is not only look after only one function, but multifunctional workers, only to give some, a job will not be monotonous, it will be something different, some creativity. So those who are according to management science, they must be learn what is job enlargement, job enrichment, all that. So this is what happened. Then next came the Industrial Revolution 3. In the Industrial Revolution 3, computer science come into place. Okay, so they came with digitization, then computers, automation, then IT technology, telecommunication, all this developed in the early 20th century. Then invention of the microprocessor, internet, then what is change that has taken place? That is from the heavy industries, what has taken place is the Industrial Revolution 2, mass production, what has taken place. Now it has come to the knowledge-based economy. Knowledge, if you have good knowledge, then that can be solved in the market. If you have some innovation, some new ideas, some creative things if you develop, that can be solved in the market, otherwise nothing. Okay, so the concept of mass production has changed to knowledge-based economy. Okay, so that is what the Industrial Revolution. Now in the Industrial Revolution, we will find the global connectivity, increased productivity, but everything would depend on digital. That is digital. Then we didn't stop there. We moved further. That is the Industrial Revolution 4. In the Industrial Revolution 4, what you see these days, the present day is the Industrial Revolution 5, not in 4. Where so in the Industrial Revolution 4, there is a integration of smart technologies, IoT, then AI, robotics, big data, that is what it is. So, what is exactly IoT is? What do you understand by IoT, Internet of Things? Give some small examples.
The device is controlled by internet.
Internet. That means you use the internet. Suppose you are going outside and you forget to switch off your fridge, refrigerator, and lights of that area.
Smart automation.
So there, through mobile you can do that. Okay, this is the through internet. The physical and cyber system is connected. Okay, so that is what is important, and that is IoT. Now, if you look at the patent grants in India, software is not granted as patent in India, although it is granted in other countries like Microsoft Word. That is a patented in USA, but in India it will be copyright only. Like books, it will be copyright. It cannot be patented in India. Okay, but if you look at the patent applications in Indian, to go to patent site, Indian IPR site, and see, patent application is mainly in software, but software companies India like TCS and others, they apply most. What is that? That means they find some solution through hardware, they will solve some problem. It is that if hardware will be interfaced, embedded system, if hardware will be interfaced, then that software will work. Okay, like your mobile is an embedded system. It is the hardware as well as the software. Right? So this is what the trend is going on. So in the Industrial Revolution 4, we talk about artificial intelligence, IoT, robotics, and big data. And what is its impact that has taken place? Increased automation, improved efficiency, and personalized product and services. And what is the most challenging part is that is the data security. Your personal data security. That is that. So we have come across many times that Google is violating the norms, and your data, personal data is being made public, all these things. So many top software companies, they are suffering all these things. Their price concern, workforce displacement due to AI and automation. So when Industrial Revolution 4 came, the major issue is that we have to equip ourselves as per the technology. That is not it. That is a challenge, because I don't have any knowledge on IoT, AI, or big data, but it is demanded that you should have that knowledge. So the traditional knowledge is no more required. You have to adapt yourself to the changing scenario. If you, any software company, if you ask very senior managers, those who are on the experience of say 20 years, 20 years like that, they feel themselves unuseful or not needed, no more needed in the industry. Those kind of things, because they were using only the software or getting the development. Now what has happened these days, the basic truth is that those who read the computer science and engineering or IT or that, Indian universities from India, basically they were applying coding jobs. The job the company was offering is the mainly coding, they do the coding. Now these days, artificial intelligence is to the coding time. If you go to ChatGPT or any software, any AI tools, and say I need a MATLAB code or any code on that, then automatically it can give you the code. Okay, so the coding part, which is already automated. Okay, so no more the manpower is required for coding. They have to do something different. Okay, so the jobs as far as coding is concerned, that has declined in Indian software firms. So if you look at how the industrial revolution has gone place, at the end of 18th century, the industrial revolution, introduction of the steam-powered machines. Then second is the industrial revolution, introduction of the electric power machines. Then third is the industrial revolution, that is the king of electronics and IT. And the fourth is the industrial revolution based on cyber physical systems. That is what we are here. So now as the industries are industrial revolution is taking place, it is taking place, the complexity of the system has also increased. The things have become very complex and very difficult to understand how the system complex is. Okay. So you can define industrial revolution. Maybe it started in Germany. It is nothing but the integration of the existing systems, but in a coherent manner. So Industry 4.0 denotes the real-time, intelligent, and horizontally and vertically network integration of people, machinery, objects, and ICT systems for dynamically managing complex systems. So the concept was originally started in 2011 at Mahapatra Industrial Fair, and it was further developed by the same man in 2013. So this is what the definition. Industry 4.0. What are its pillars, or what enables industry 4.0? That is the cloud computing, advanced robotics, simulation, artificial intelligence, Internet of Things, cyber security, additive manufacturing, visualization, big data analytics. These are the different components for going for industry 4.0. We look at here only one thing, that is the additive manufacturing, that is the manufacturing concept. Where the significance of additive manufacturing is that if you give any compressed model, compressed solid model, it can be sliced and additive manufacturing machine can build for it. This is what it is. Of course, it has some limitations. As you find the limitation in CNC machines, because it is basically compressed code. So the profiles that we get in the CNC machines, what is the limitation of the profiles? The exact code we will not get, because it is small elements. That is, so that same problem exists. And another is the staircase effect, that is the staircase effect that still exists with the additive manufacturing system, because those words implemented all these things. So, but still then, and material limitation is also there, but still then additive manufacturing is very convenient way of manufacturing using the digital methods. That's why it is one of the part of the industry 4.0. So these are some of the definitions of different pillars of the industry 4.0. That is Internet of Things, which encompasses physical devices via Internet. These intelligent devices gather data, interact with their environment, communicate with each other in real time, and initiate actions online. So consequently, IoT links people and objects at any time and place using any network or services and connecting with anything or anyone. This is what the definition of the IoT. Then second one is the visualization of technology, that is the augmented reality or virtual reality. Here we can visualize. We use the digital tools to visualize the whole factory, whole industry that we can visualize. So then take a decision. So visualization technology enhance our perception of the real world through visual augmentation. These digital tools offer a virtual model of an entire production system and their interactions around the supply chain, driving significant changes in how business customers train their workforce and design and develop products. So here we can make a lot of then scenario and changes how we will do the product. Then the cloud computing. Everybody must be knowing what is cloud and the cloud computing. Okay. Basically, cloud is where data is stored, and we can get the data from it. You must be knowing Amazon. Okay. If you get the Amazon order, then it will be written AWS. Parent company is AWS. For your information, I can tell you that Amazon retail business is not the major business. It is storage and data storage, and that is their main business. Okay, so the cloud servers are there, and even Microsoft has clouds from Amazon. So basically, if India would have use this huge data storage capability like Amazon and Data, then you would have a big company. You would have a big company here. Then next is the cyber security, which focuses on safeguarding private information. Then next cyber security is that. Then simulation and modeling. What is the simulation? Simulation. There are many types of simulation. I can give you the there are basically two types of simulation. One is the discrete event simulation and another is the continuous simulation. Okay. Now, suppose a enemy player is going in your area, then you have to fire a missile. Okay, that missile will take the projectile motion. Now, this projectile motion can be given as a differential equation, can be solved as a differential equation. This differential equation time t is there, so that can be continuously changed, simulated. That means each time when the time changes, continuously time changes, and you can fix the target, how the target can be destroyed. So this is what called continuous simulation. Your time t changes continuously, which is given by the differential equations. Is it clear? In contrast, there is a discrete event simulation. Now suppose I want to know the efficiency of the teller person who is in a bank. There are teller counters, so there are long queues. Okay, queues are there, and the teller officer, he will be serving the people, serving the customers. Now here, what happens? The event changes when a customer enters the queue or leaves the queue. The status of the system changes at the discrete point of time. Is it clear? It is not that like in the projectile motion, every time it is changing. Here, an event will take place, either a customer comes or leaves. So once the service is given, we will leave the queue. So that queue length, that will changing at discrete point of time. It is not continuously changing. This is what called discrete event simulation. So sometimes we need continuous simulation, sometimes you need discrete simulation or simulation. Then I want to simulate a factory. Necessarily it will be a discrete event simulation because jobs will form the queues before the machines. Okay, my jobs for the jobs in process that will form the queues before the. So the simulation can help you to find out before actual solution to find out what is the efficiency, effectiveness, and the productivity. All it will give you some idea. So how it will help you? It will help the managers to take some decisions. It will help the managers to take the decisions what to be done. Suppose you analyze using the discrete simulation that your teller officer is very slow and usually there is a wrong. So the manager will think either the manager will think to open another new teller counter or remove that of inefficient officer. So that decision that we take is in the discrete simulations. Then machine learning and artificial intelligence. Machine learning is just a subset of artificial intelligence. Okay, machines learn themselves. They do like those were acquainted with neural networks. What the neural networks do? Neural networks never does anything other than the regression method. Okay. In the regression model, you use y equal to x1, x2, x3 like that. That's the multiple regression method. You develop some equation. In the neural network, we use the neural model, neurological model, human brain model, and train that. You give the inputs and the output, and it will learn the patterns. It will learn the patterns of the data it can learn and predict them. So this is what kind of artificial intelligence you use or build the artificial intelligence in the machines. Like even small toys, Chinese toys, you purchase it for 20 or 30 rupees. They move around and they find the obstacle, they return back. This is what the artificial intelligence is. Okay, it has the intelligence, artificial built on that. Okay, by the sensors, it is usually the sensors can sense and give the command that it should move. Right. So in the many machines use the artificial intelligence and the machines learn through artificial intelligence, like swarm of robots. You train them, and they move in the direction to be there. And if the obstacle is there, they will give you the signal. And like that, swarm of missiles, swarm of bombs, all these things we have come across in Operation Sindoor and this Israel and Iran war. All these are artificially trained. Okay, and machine learning capability is inbuilt on that. Okay, so then there is a big data analytics. Big data is a large volume of high velocity, complex and variable data that require advanced techniques and technologies to capture, store, distribute, manage and analyze. This is what the big data. And using the big data, we analyze what is going to happen. Now, how the big data will help you? I shall give a very small example. Suppose a company is in the retail business, like Madura Fashions. That is a Birla company. All the shirts, share and whatever that brand you take, that is sold by Birla. Okay, Madura Fashions. Now they have big data because all the sales data they are having. So very big data. Now the manager who is in the back end, in the sales back end, he has to think that what is the stock to be sent to Bhubaneswar or to Delhi, like that, and what is the model, whether because customers in Bhubaneswar are different from customers in Delhi. Okay, what is the price range? What type of cloth? All these things they analyze from this big data and find out what is to be sold and what time is to be sent to their stores. So this is a very big job. Those who are in the sales and marketing, they must be knowing how they play with the big data. Those who are in the supply chain also, they must be knowing how they play with the big data and then to make the decisions how to do that. So then as usual, additive manufacturing I have told you, that is the 3D printing. Then advanced robotics includes autonomous and collaborative robots. Then come to any question on industry 4.0, how it is accumulated and how it is working. It is very easy to talk, discuss, but very difficult to implement. I am coming to that. Already slide by slide. What are the challenges that are there, and all these things happen. The very easy to discuss, read, but creating that environment is very difficult because we lack in technical skills. India particularly lack in technical skills. We don't have that technical skill to develop. So we have to go long way to approach the industry 4.0. The industry 4.0 and 5.0 only difference is sustainability or environment. That is the only difference. So industry 5.0 focus on human-machine collaboration rather than full automation. AI and robotic assist human instead of replacing them, because human beings fear that robots may overpower, one day they may overpower human beings. That's why they made it AI and robotics assist human instead of replacing them. Then personalization and customization products and services, sustainability and ethical manufacturing become priorities. Ethical manufacturing is very important because we find many unethical business practices in our system, and greater emphasis on creativity, well-being, and balanced work health. So the pillars of 4.0, 5.0 are more or less similar. Only change is that that is the fintech, financial technology. Fintech, that is the bringing digital currencies, digital transaction system, stock and financial investment system, enable exchange in real time. So that is the financial technology. Or you find it is different from the fintech companies. That is the fintech is the financial company, is the technology. Here we talked about the digital currencies. The government of India is also looking for the or trying for digital currencies, and also these bitcoins That is also a digital currency. Then holography. Holography is used for it is a imaging process where you can measure the data. Mainly used for the measurement. Then bionics is a science of building artificial systems that are characteristic of living system. It is the technique of imitating nature. It is about copying nature but understanding how things work in nature. It can help in making a healthcare industry resilient. So, to look for this and a digital twin is a digital representation of the object. It is often a digital replica of the object within the physical world, like a reaction propulsion engine, wind farms, or more oversized items like buildings or offices. All these are the few changes that are digital twins, where you can completely digitize the whole, even this college can be digitized. See. And while it's used for the to use the biological solution for the chips and all that. Then green computing. So green computing is defined as the technique of using the computer system in eco-friendly manner. Next please. So these are the only changes. So the concept of Industry 5.0 and Industry 4.0 nothing different. Is the similar technologies. Only thing is the sustainability that is important and more centered about the human beings. Next. Next. Government of India made a bigger role in making Industry 4.0, that is NIT India, Digital India, Smart Cities. These are some of the examples of how. Then India has another advantage that we are good in AI and IoT and automation and expansion of startup and digital economy, that is promoting innovation. Skill development initiative to adopt Industry 4.0 technologies. Then here comes your question. The major thing is that upskilling of the workforce. We have actually our workforce should have and they should like the digital system and the changes that we have, what are taking place, we must be adaptable to that. And we have not gone through that process of education, and all of a sudden we have to do that, and we have to be, of course, these days many institutions they have started AI/ML courses, many courses they have started, so gradually we are doing that. And another important thing is cyber security. Cyber security is still a challenge. Then we don't have the infrastructure. Major everything you have to depend on foreign countries, like for the chip manufacturing and for storage of the data for clouds. And we don't have a sufficient infrastructure. It requires time. So whatever we have started in a very small level, and I mean it is not integrated at the basic level. In the say artificial intelligence we started something. We have started in additive manufacturing, we have done something. But we have not integrated everything to be called as Industry 4.0. Okay, that is a major challenge. That is, because our labor force they have not changed. There still challenges are there, but we are in good track. The thing is the government initiative. Next please. Next. So, next. Next. So, there is a these are the good government initiative like strengthening of STEM, science, technology, engineering, and education. Government has started this. Central government has started this to equip the students with industry 4.0 sector. That is for the STEM, where science, technology, mathematics, everything. And encouraging startup and innovation of to drive industrial transformation. Government policies for sustainable and green energy adoption. Government gives a lot of subsidy in that. Then investment in AI, robotics, and smart manufacturing. Ensuring digital literacy and inclusive growth to reach technological growth. So we have some positive things and some positive aspects as well as some negative aspects. But still that we are moving towards digital industries. Next please. Another chapter. Anyway, so I have given some idea on what is industry 4.0, 5.0, and what are the challenges that we are facing, and what are the opportunities that we are having, different pillars of these two things, and how the additive manufacturing is related to it. So with this, I shall stop here, and if you have any questions, you can ask me.
From which regions specifically came to? Actually, initially this construction downloaded that it is to 20 So which year onwards?
This is a
Sir, when around 2000 people started that classifying when the concept of industry 4.0 came. But this industry 1, 2, these were already existing, and they have not been named as industry 1, 2 like that. But when the industry 4.0, a different name is given, then only 1, 2, 3, all these things. Only after 2000. In fact, 2010. Yes, I think no question is there. Thank you very much for your patience.
Thank you, sir. Thank you, sir, for your nice talk. The section will be very practical and very interesting. And I would like to request you, sir, Principal sir, Professor Arjun Mishra sir, to participation our guest with activity Mr. Prasanna Kumar Mohan sir. Please, sir.
This is read item.
Thank you, sir. Now we will move for lunch. At lunch, after 1 hour, we will catch here all of